Hello and welcome to the Crispy Fish, Omega-3 for your brain. I'm Christopher and today we'll be talking about awk. This is part 2. Let's get right into it. So let's get more in depth with awk. Let's start off with this command ps. It gives us the process IDs. We don't want the headings at the top, so we'll just use a built-in called number of rows. And we'll just print out the number of every single row followed by the whole line so we know what we're dealing with here. So the headings are row 1 onwards. So if we use a conditional statement here, we can just say we want a number of row that is greater than 1, and we'll get everything except that top heading. So we can also then add on to this statement by using print $1 just to give us the first field. Now we can also use awk as what it is, a programming language. So we can use fancy things like control structures, for instance an if statement. So if we go ahead and add our first condition here to say we're looking for a row higher than 1, we can look for process IDs in the first field that are higher than 3000. And then if that condition is true, we will print the first field and we'll print the last field, which has the name of the process. So to add to this control structure functionality, awk also has some built-ins. For instance, we can use to lower, and we can print every line in lowercase, and that will make our terminal whisper to us. There's also another built-in called to upper, which can make our terminal shout at us. We've been using awk expressions from the terminal so far, but we can also read and run these expressions from files. Yes, we can write little programs with awk. So let's make this whole programming language thing real by using a language server and an IDE. My language server here gives you what the beginning and end keywords do. You can pause this to read this if you'd like to, but I'll also give you my own description. Begin evaluates all the logic that we're going to execute before we read input. This middle section here is the logic that executes when we are reading records into awk. And this end section is what executes after we've read in all of that input. Now the main benefits of this approach is it eases writing awk expressions since you can write them in a separate file. Second, you get some portability because you can copy your awk file to another machine and share it with the co-worker and they can use it too. So we can write a little program that doesn't even evaluate any input, and it'll just go and calculate numbers from 1 to 20 and tell us which are odd and which ones are even, how much of each we have. So if we use our begin keyword here, we'll start evaluating this before we read inputs. So you'll see I have a for loop here with a counter that starts with 1, it's got a condition when it will end, and then it increments that counter. Then I use a modulus here, which basically is a fancy word for saying something that divides a number by another number and leaves you with a remainder. If we divide 4 by 2, we are left with 0, which is an even number. If we divide 5 by 2, we're left with 1, so it is odd. And that's how we evaluate this logic. And then we'll go ahead and we'll increment these counters. We don't even have to define these counters before. As long as we increment them, they would have started at 0 anyways. Lastly, we'll print out the result of these counters. So if we go ahead and run our file here, you'll see that we get the expected result. So we've used a whole bunch of different control structures in this example, but there are many more. For instance, arrays. So let's demonstrate arrays by solving a problem. So I've got an email list here with a bunch of duplicates. Let's write some code to solve this in an awk file. So we'll create an array called unique and we'll set the contents of each line to the key of that array and send the value to 1. And at the end, we'll finally print every single value. Every time we have a duplicate, we would have overwritten that. If we go ahead and run this, with our piece of code here, you'll see that we don't have any more duplicates. Wouldn't it be easier to deal with this data if it was in alphabetical order? Let's use awk to solve this problem. So we set n to 0, then we set every record's key to an incremented value of n, and we store the content of $0 in there. At the end, we use asort, which I read array sort, to assort the array, and then finally we print this out. And if we go ahead and run this file, you'll go ahead and see we'll take our unique inputs, and now it'll also be in alphabetical order. Now awk has a bunch of built-in functions to help us out with every problem we might want to solve. For instance, let's say we have a database that only accepts numbers that are 8 digits long. We could get awk to shout about it. We can go ahead and use the length function here to check that the second field of our data is not larger than 8. And if it is, we'll print that that second field is too long for the lead, which is in the first field, and we'll print the row number. So if we go ahead and run this, you'll see it does in fact mention that there is a number that is too long for a specific lead. Now there are a lot of these functions, so we won't go over all of them. Awk's documentation is quite extensive about all the functions that it has. Let's say one of our leads has a change in their organization's domain, and we need to use awk to fix that. Let's use the gsub function to go ahead and fix this. So here we call gsub. Now the way gsub works is you give it a regular expression, what you want to replace it with, and the string you're replacing. In this case, we're replacing field 3. At the very end, we're going to go ahead and print the result. So if we go ahead and run this, we should see that gsub has now taken out the old incorrect address and replaced it with the new corrected address. And even though the formatting needs a bit of work here, it has indeed replaced the address. If built-in functions aren't serving the purpose for what you are trying to accomplish, we can also use our own user-defined functions in awk. We define our function here with the function keyword. We give it a name, in our case multiply. We pass it a parameter here, and then we use that parameter here in the function body and times it by itself. We then use the return keyword to give the result of that back to whatever is calling it. Here we print the result of that function, and we use argv, which is a special built-in variable in awk that contains all of the arguments that we passed an awk file in an array. In this case, we're taking the very first argument we passed to that file. So if I go ahead and pass this a number like 5, we'll get the expected result. And we can do this with a few numbers, but the main point here is we can give the awk file input to change its behavior. Thank you for joining me on part 2 of awk. I hope you've really found value in this, and that you now know this true power of awk as more than just a utility, but basically a whole programming language, and what it could really do for you when you're working in your daily life and you need to transform and manipulate text. So if you found value out of this, show your love in the comments and like and subscribe. If you have a interesting thing you'd like to share, go ahead and share that in the comments, or if you just have something to say in general. If you're looking for your next video, you'll find it over here.